Volumes of revolution. We've been studying area, correct? We're going to take that knowledge and we're going to make a three-dimensional object out of it. Okay. So part of the challenge some people have is actually visualizing these shapes. Hopefully we can help you there. So what you want to pay attention to is that we are calculating an area and we're going to spin it around an axis. Okay. You do not have to worry about shells. Do not worry about the red one. Okay. All we have to worry about in AB is discs and washers. If I said, okay, what does a disc look like? Yeah, it's the flat cylinder, actually, right? It's a circle, though. Right, a frisbee. What about a washer?
It has a hole.
Yeah, it has a hole in it. Okay, so can you imagine the hole is the top minus bottom functions because there's going to be some area taken out. Okay, so what we're doing is basically taking these functions and we're spinning them around an axis to create a three-dimensional object. That would be a washer. Okay. This is a y integration problem, so it would be right minus left. Okay, we will do x integration most of the time. All right. Okay. So that's basically what we're going to be doing. Okay. So what shape did this make? You said a circle, right? We're going to use that area formula of a circle to build our volumes. Okay, it's just like the volumes on the base that we have been studying. All right. So let's talk volumes of revolution. Okay, let's look at this. Looks like the square root function. Correct? Looks like it. It's just a sketch. We will consider it from, let's go to 9. 0 to 9. What shape would I make if I revolve it around the x-axis? So if I took this shape and spun it around. Okay, never heard of that one before, but yeah, that's a decent assertion.
Yeah, laying on it.
We need to pull up the picture.
Yeah,
Yes,
it does
it
that.
is.
yeah, looks like a shot.
You could look it up.
What else?
You gonna look it up.
Pasta? What kind? Penne, rigatoni, macaroni,
Elbow.
elbow.
Macaroni.
What else?
When they come in a box. He's gonna look it up.
Yeah.
There, okay, there's the Pope's hat.
Awesome.
Okay.
Swag. Swag.
I don't know what pasta shape that would make, honestly. Here, let me, hey, oh, that's great.
cat.
And then the washer is a little pineapple on top of the hand.
Okay, there you go.
There you
Okay,
go.
we're getting somewhere now. All right, so you can kind of visualize it. You don't have to, but it helps. You know, kind of, it helps me because I'm a geometry nerd. Okay, so if I were to calculate the volume of that shape. Mention the teams. Okay. I know.
I just shake my head, yeah.
What shape does this make? It makes a circle, correct? What's the radius of that circle? This spot is 9, but in general, it's R, right? So the volume from 0 to 9 of pi r squared. Yes. The difference is we're revolving around an axis instead of placing a shape on it. It creates a difference.
So this is like the whole shape is just like that.
Yeah, it's just one block. It's a solid in this case. Okay, it's a hand. Let's talk it through. Does that make sense how we build those formulas? Okay, so this would be pi x, correct? Okay, I want you to calculate that value right now. This is part of that practice we need. So go ahead and run that integral through on your paper. You can leave it in terms of pi, that's fine. Survey says? Check your work. And there was a lot of messiness on your quizzes. Since I'm not scoring your AP exams, you need to be a little more, they're used to looking at junk, but I want to be better than everybody else. So make sure you're nice and organized and neat. Okay. That is 81 pi. Right? Do I need to subtract the 0? No, because it's 0. Don't count on this being 0. Okay? Just don't count on that. But it happens to happen. It happens.
Stand on a corner, like right there.
Next.
It happens to work out that way.
Thank you very, very much. Thank you. That's awesome. Okay, how about calculate the volume of the solid generated by revolving y equals x squared around x-axis or 0 to 2. Just a kind of a slightly different way to write it. It is an interesting shape, actually. Yeah. No,
Will they
You'll have
have
to.
it for you?
if it's a pre-response, you usually give them the picture. Yeah, but multiple choice, probably not. 0 to 2, correct? It's, I just didn't finish this. Now, we revolve it around the x-axis. Okay.
When I go down to sleep morning, then.
Yeah,
I don't.
yeah. I read Green Eggs and Ham so many times this weekend. Do you like Green Eggs and Ham, Sam I am? No, I don't like Green Eggs and Ham, Sam I am. I do not like them in a house.
People are gonna be watching.
Do not like them with a mouse. Okay, never mind.
It's okay.
Okay, so you gotta see the shape, but again, what do we have here? And the radius this time,
Green egg.
it's just a different function. So what we find now, put the pi out here if you want. It's the same formula every time. Pi r squared. It's a constant, you can move it up. If you look in your book, that's the formula they give you. So you're just plugging the radius in. That's all you're doing.
And the radius is always going to be the
It's-
function, but
Yeah, in this case, since we have no, I'll show you, this makes a disc, right? It's got no follow.
all monsters.
Washers will be a subtraction. It's, so, okay, practice that up. Go.
Can you multiply that thing by like?
I
Yeah.
don't care what you do.
Okay. How do you spell it right on the outside?
X to the what?
You just add the pi and into family integral?
What did you say?
You just add the pi back and into family integral?
If you can, if you want, it can be in here right at first. Multiplied constants can be moved outside. Oh, yeah.
On Thursday and Friday.
Very much. Alex, you're acting like you're sleeping. What's the integral here? Yeah. The antiderivative.
Pi x to the fifth over 5.
Evaluated from,
-2.
okay? And what's the answer, Caleb? Bueno. Good? Okay. Like I said, we get lots of practice with this stuff. This will help you with the ones we talked about earlier in class, and lines on basic. So, let's do one more. A washer. For the examples in the book, sometimes. Sometimes. Okay, find the volume.
You don't see it.
obtained by revolving the region between y equals x squared plus 4 and y equals 2
Oh,
about x axis for 1. So first thing we notice, got two functions.
Is that polynomial maximum?
Usually. Yeah.
There's two functions.
Usually that's the case. Remember x squared plus 4, the y-intercept is 4. And then y equals 2 from 1.
Oh,
This is our region. So this is a picture of what we're looking at. X squared plus 4, y equals 2. And then between 1 and 2. We need to rotate this around the x-axis. Right, so you want to reflect everything. What you end up with is a big shape. And what the end looks like a washer, right? So what we have is an outer. Remember, top minus bottom still applies here. What's the radius of the top? That one, right? So we have an integral for that.
So you find in the whole thing.
So we have right? That's the big one. And now we have to subtract out the small one, right? It just needs to be hollow, correct? What's that radius? Yeah, 2. So like I said, you have two integrals now. If you want, the formula in your book writes it like this. Let me get rid of that pi first. These are equivalent statements. They both have a pi in them, so I can write that up front if I want to. And then it's outer minus, or top minus bottom. Sometimes your book will say outer minus inner, because it's a washer, you have an outside and an inside, right? So your book will say outer minus inner.
Yeah.
Your general formula radius of the top minus radius of the bottom, you square them both. Okay? So identify top and bottom, plug it into the pi r squared volume formula. Any questions? Okay, we're gonna do a couple more tomorrow. This I'm gonna ask you to have done for tomorrow. I wanna check it. Then so tomorrow we'll do a couple more of these, with washers, harder washers. Thursday we'll do Y integration, Y revolutions. Friday we'll just do some AP work on. Okay, so tomorrow. And the rest of the week will all be due later, considering what's transpiring.
What's gonna happen here in 3 days?
Okay.